Yeah, good afternoon, guys. All you guys are doing okay. I'm going to, since we're kind of behind, we're going to be um, I'm going to doing like this makeup session, and basically I'm going to be covering some concept. Today I'm going to be covering uh, max term, min term, NAND and all gates, as well as K-map. Okay, let's just get started real quick. Give me a second. Let me know if you guys can see my screen effectively. For the year. So we're gonna start with the min term and max term. Mix term basically like grouping ones on a truth table, and max term grouping zeros as well. So for instance, let's say we have such a truth table with A, B, C. Let me just draw it real quick. Have a truth table with A, B, C, A, B, C. Okay. Have Y. Okay. Like this, I have 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, second, 0, 1, 1, 0, 0, 1, 1. Hopefully you can see my screen. Let me see. Sounds like it's not there yet. Let me see. It's supposed to be here. Actually, 1 second. Okay, it's right here. Okay, this is my key map here. Hopefully you guys can see it. Okay, right. So basically, this is a given key map. And this key map we have output 0, 0, 1, 0 and 4 ones. 1, 2, 3, 4. Okay. Okay. So now I have you know for we call this like a for we have what we call like a product of sum, right? POS, which basically consists of you know the zero being like the actual value or numbers, and the one to be its complement. Okay. So for instance, if I have a number A, know, 0 represent A, and the 1 represents the complement for a POS, meaning a product, also called product of sum. Product of sum. So, okay. And then we also have the SOP. SOP, sum of product. Sum of product. Okay. Where the 0, in this case, represent the complement, and the 1 represent the actual number. Okay. And now, in this specific, for this specific table here, right? If you want to represent it as max term, that means we're going to group in the zeros, okay? So we're going to be taking the zero, this one here, this one, okay? We have 3 0. Let's call this one and this 0 here are the max term. Basically, we're taking this one as max term because we're just grouping the zeros basically. So we're going to have y equals to a or b or c. That's the first one. This is equation 1. If you want to, right? Equation 2 for this 0 here. Equation 2, let me start here, plus A or B or C bar. And you see again the zeros represented by the 1, the zeros represented by the A, and the 1 represent the complement. Okay. Or sorry, it's not or, it's dot. Okay. Dot that represent A or B bar or C bar. Okay. That's max term. So this one represent this one here. This one here as well. Okay. equation 2, equation 3. Okay, and this is the max term. Okay, so this is our y equation. Similarly, right, if we want to have the y bar and complement, basically, I'm going to just put like a bar on this one here, right? If we want to then transform this SOP into a SOP form, y bar of this one will give us basically putting a bar on it, right? Y bar is just basically put the bar here, give us A, B bar, C bar, A bar, B bar, C, or A bar, B, C. Okay, so this SOP. Next, we have so alternatively, let's say I have like another function. Let me create. Does that make sense? I hope. Yeah, let's not create another function now. I'm gonna erase everything here and create a new function here. New function with a new output. Okay. So another way of representing SOP or POS for max term and min term as well. So let's say for that same function there, let's say I have the same thing. It's called like a Y as well. Now I just generate a new function. 1, 0, 1, 1. 1 second. 1, 1, 1, 0, 0, 1, 1. Okay, that's what I've got here. And then I'm going to present this one as a min term, right? Min term is basically like a sum of min term. In this case, y of a function of ABC presenting min term basically like a to represent this one in min term. I will just basically another way to represent it, summation of min term, right? SOP is also like for min terms, okay, right? And basically like circling the ones only. So this one here, equation 1, equation 3, 4, 6, and 7. Okay, as I mentioned, equation 0, 2, 3, 6, and 7. Okay, so what else are the min terms? We could present it with a summation sign and a little m. Conversely, for the max term though, it's basically like a summation y of ABC also. Instead of the, since it's a max term of POS, present it with the pi sign. Pi basically means like a, pi sign means for POS or max term. And now instead of a small case m, have a capital case m. It's basically with a 1, 4, and 5. Which basically just 3, 0, this 0, this 0, and this 0 here. Okay, only right. Hopefully that makes sense, and you guys can extend it as well if you want to. What else? That is a min term and max term in general, basically. And now I'm going to cover real quick. Let's do, I guess, some. Yeah, that's min term, max term. Let's do, another kind of a quick problem. Let me just erase this one real quick. Okay. Like last problem, and then we're going to jump to NAND and NOR gate. Let me know if you have a question by email. Going to office hours on Tuesday as well at 7 p.m. as well. So, okay. Right. So I have A, B, and Y. And Y. I have 0, 0, 1, 0, 1, 1, 0, and 1, 1. Okay. So if I'm just giving me like a random function like this one. 1, 0, 0, 1, 1, 0. Okay. So if I want to represent this one into maximum form, I'm just going to basically take this to 0 here, right? Basically, y equals to, right, maximum pi of what again? Sorry, pi of capital M, because it's a maximum form of what? Any guess? Of M1 of 1 and 3. Okay. In this case, we're going to give us A or B bar A bar or B bar. Okay. And again, you can just also look at my slide as the discussion lecture for how I reduce this one here. Basically, you can reduce it by just doing some development here. Okay. If you reduce it, it's going to give you y equals to just a b bar. But I'm not going to do it here since the purpose is basically just to show you max term and min term to do that with you guys. Okay. SOP. So that's that one. Sum of product. Sum of product. Yeah, that's pretty much it with the min term, max term. Okay. Yeah, I guess we're gonna go through some extension tomorrow. I guess doing discussion. Yes. So let's now switch on to NAND gates and NOR gates real quick. Then we'll end up with came up. Give me 1 second. Sorry. Okay, so if you're given actually let's go through came up first. Okay. For instance, if I'm giving a function like right 1 second. Yes, if I'm giving a function like such as give me 1 second, I'm just trying to find my notes real quick. Yeah, I'm giving a function below here. Just the way what I've got so far. Alright, so if I have this function here call map yeah, I'm giving the function summation of now we're going to review real quick maps first. Alright, so I'm giving the function f equals to a b c, okay, which is summation of m. Since you see the summation sign and you see the little case m, it means it's a SOP, okay, or min terms as well. So basically 1, 2, 1, 3, 5, and 7. Okay. Okay, so the way represented here in the schema basically it is and also if you have three variable here, three variable, that means we're gonna have 2 to the cube, which is basically eight possibilities. Okay. So let me draw it again. Meter here downstairs here, down here. So I have this guy here, 2, 3. Okay, I have ABC, my ABC 0, 1, 0, 0, 0, 1, 1, 0, 1, 1. And the way that actually the other way around, 1, 1, 1, 0. And the way that that it works is basically like a K-map is basically kind of a map. So like you can work on this one min term 1, okay, min term 0, sorry, min term 1, min term 2, min term 3, okay. It's too little. So let me just do something bigger. It's too small. Okay. So we have our ABC 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. 0, 0. So I have min term 1, min term 0, min term 1, min term 2, min term 3, min term 4, min term 5, min term 6, and min term 7. Okay, right. As you can see, right, for the first one we have 0, 0, 0, 0, so min term 0, and then 0, 0, 1. Okay, min term 1, and so on and so forth. Okay, so basically we have min term 1, we have 1 first of all, right, which is basically going to be here, and then we're going to have 3, which is going to be here. Okay, and then we've got 5 and 7 as well. 5 and 7. Okay, yes. Okay, and since it's midterm, we just present the 1. This is how it came up. Supposedly it came up. And basically, the grouping sounds like, we present with two exponent, right? We can a two grouping. Like for instance, we can make a grouping of 2, right? Of 2, 1, 1. Two grouping, right? Like this one or like this, or we can have a grouping of 4. So basically, like a grouping of with two exponent. Be a grouping of 2, grouping of 4, grouping of 8 is the maximum. Also go 16 and so on. But in this case, we're going to stop. We mostly do like grouping of 2, 4 mostly, and we don't have and 8. Yep. In this case, we have a grouping of 4. We have 4 ones here, right? Basically, right. And the way we read it is we read it as everything else we put as zeros. 0, 0, 0, 0. Okay, this one is be written as we see where the things are identical, like this one here. When in these two column here, where the ones appears, what is the variable that doesn't change? Here we have 0, 1, and 1, 0. What doesn't change is the right side here. So 0, 1 is BC, 1, 1 for BC. Which variable doesn't change? When I go from min term 1 to min term 3, is the one that changes for the which is C, which changes. Okay, and on the left side, it's not on the vertically, A changes from 0 to 1, so we're only gonna have C here. Okay, so our function f, right? F function f or f of ABC is basically equal to C. F of ABC is equal to C. Okay, and we're gonna go through more this. We're gonna go through more of this tomorrow. Give me 1 second. Hope it's still recording. Yep, it's still recording. Yeah, we're gonna go through. Yeah, any question? Any question? If you have this question and this one, let me know. So that's like came up thing. What else? Let's say I have also an example 2, right? Example 2. I have f of ABC, summation of 0, 1, 2, 7. Okay. Alright, so I'm going to have ABC 0, 1, 0, 0, 0, 1. Alright. Alright, so basically I have min term 0, which is this one here, right? Min term 0 as the other one, min term 1, min term 3, sorry, min term 2 first, and then min term 3, min term 2, min term 3, min term 4 here, min term 5, min term 6, and min term 7. Okay. So basically that is a min term 0 that we have. So we're supposed to have like a 5 of them here, right? 5 ones here based on this what we have here. Okay. So I've min term 0 already. 1, 2, okay, 4, and then 7. Okay. Now we move forward to do our grouping. Okay, we're gonna grouping like these two as I mentioned. Okay, and then we're gonna do this grouping here, this grouping here, and this one here as well. Okay, all right. Grouping, this grouping here is gonna give us what B bar C, right? Because vertically going A is changing, so we don't take A. Horizontally going B and C bar because it's zero. It's in the meantime we take zero is complement. Okay, and we have 0 0 which is B bar C bar. The second grouping we have this one here, which is basically A bar B bar. Okay, and the third grouping we have ABC. This one is ABC, right? Because we have like vertically speaking, we have A, this one here, okay, and we have BC here, okay. It usually give us ABC. Okay, and then lastly we have A bar C bar here. Because vertically again we are here. So that's pretty straightforward. Right? So that's pretty much it for actually no. This one is actually the way we group the last one is not like that. Grouping, sorry for the confusion. Grouping the last one as like this one here with this one here. Because the K-map can be formed as a cube basically. So the two extremity or the two inside should be covering together, and that one give us A and C bar basically. Because these two here, what changes is basically the what doesn't change. So it's C bar, which is the last 0 0. So it doesn't change, and then vertically speaking, you're on A bar. Okay, this K-map pretty much basic covering K-map. Now let's cover real quick NAND and NOR gates. Let me know if you have a question, concern, comment. Once again, question, comment. Okay, so NAND and NOR gates, right? Okay, so if you're given a set of function, let's say so we have here function f is equals to ab or b c or g. Right? If you want to represent this one like using NOR gate, for instance, right? What we can do, let me just zoom it out. Hopefully you can see it. Right? You want to represent this one using NOR gate, right? Now we're gonna learn a NOR gate. The way we do it basically is we basically put a bar on here, right? NOR gate means we only want to have a the plus is mostly involved here. Right? We don't have to want to have a dot with this multiplication here in the middle. Right? So what we do is basically put the bar on top and we have like the bar like to show you here like this. Put the bar like here and we put the bar here. Okay. It becomes A or B, the whole thing bar plus C or G, the whole thing bar. We basically apply the Morgan theorem. Okay, this is the Morgan. You guys are very familiar and like very, very well. Okay, now here is basically our since everything else now here is yeah, right. And now here also we need to have like an additional bar here because if we do it like this, it's not really going to work, right? We're going to add another in order for this function here to equal this one here, because we know that f bar right typically equals to f. For this function here to be equal to this one, for original f function to be equal to this one here, need to put double bar because f bar bar equals to f. Okay. If you want, let me just write it like this one instead. F equals f bar bar n equals to a or b bar or c or g bar. Like this, and additional bar, add this one up. Okay. Reference label. And now I get basically the symbol for a NOR gate is like this. An OR gate with a bubble on it. Okay. So let's draw our function. This is NOR gate. Our function using the NOR gate only. Okay. First of all, we have to input A, B. Okay. You know this first one guy here. This is the expression 1, expression 2. Okay. It's basically A with this guy here. A or B or here. Okay, and then we have also our CG here. Same thing. C or G bar. F equals to A or B times C or G. This is the ball here, and this is the ball here. Okay. So basically expression 1 that we got here. And since there's a complementing this NOR here, we put another ball on top. Okay. So that is a NOR gate. It's a NOR gate realization circuit using NOR gates only. Okay. Now let's use like using NAND gate as well. That was using NOR gate. Let's use NAND gate now. Okay. We have our function f is equal to a b bar or a bar b. Okay. So first of all, using NAND gate. Remember, NAND gate is like the symbol is like this one. Okay. And and we want to eliminate all the addition sign, all the no or no signs. So remove this plus here. In order to do so, we add the F on the top, a bar on the top. We have a bar here, which gives this one like this, right? Give us a b bar dot a bar b. Okay. And because we want to have our initial f function without a bar, f equals to f bar. Basically, add another bar to it. A b bar times a bar b bar, the whole thing bar. The second bar we add it. Okay. Now we do our function real quick. We have a like this, b bar, this guy like this. Now this is our first one. Here we have a b bar. Okay. And then we do our a bar here. A bar b into a line. It was a b bar. Sorry, a bar b bar. Then like this, they give a now you have f function f bar of or f bar, which is basically a b bar dot right a bar b bar the whole thing bar. Okay, so this is our f function or if you want, you can call it as the function we had a b bar or a b or b. Okay, because we transform our function f, which was a b bar or a b, we transform it into a bar bar, which was basically a b bar times a bar b bar, the whole thing bar. Okay, so the same thing a bar bar. Okay, that's pretty much it. We cover main term, max term, maps, none, and all. Okay, review some more tomorrow and also go through K-Macros tutorial, and that's it. And let me know your question. Bye bye.